I'm asking, so someone please take the photo of me to present this, because I was told to do so from the PR team of my company. So yeah, thank you, and you can just share it in the photos channel. Okay. So hello, I am Hiromi Ishii from JijModeling, and today I will talk about some applications of Egglog to mathematical optimization. So this talk introduces two applications of Egglog to mathematical optimization. The first is resugaring expressions involving higher order functions into comprehension syntax for LaTeX rendering. And the second is more declarative constraint detection, which continues the talk from the last year's workshop. And the first topic also turns out to be important for the second one to achieve practical performance. And through these examples, I want to share two general lessons for writing Egglog rules. First, Henkin constant-like trick is useful for propagating facts while substituting bound variables. And second, and most important thing, is that you must optimize or decompose the premises of Egglog rules. Otherwise, Egglog may not even reach equality saturation. Okay, and overall, equality saturation and database-backed logic programming fit mathematical optimization surprisingly well. Okay, here is the overview of this talk, and first start with the overview. So, what's JijModeling? So, JijModeling is a modular Python EDSL for mathematical optimization. So, what is mathematical optimization? Luckily, we have some talks about mathematical optimization, so we can just see this quickly. So a mathematical optimization problem asks to decide variables to minimize or maximize an objective function subject to equality or inequality constraints. So a typical example is knapsack problem. Yes, and in this formulation, W, N, BI, WI, all input from users, and determined by the real-time real-world settings, and Xi's decision variables that is determined by the solvers. Okay, so JijModeling is a general-purpose mathematical optimization modular implemented as a Python EDSL in Rust, and it compiles a high-level problem formulation into the solver-agnostic or mixed format and passes to the solver. And its distinctive feature is to utilize separates the model definition from the input data and utilizes the information of abstract syntax tree as far as possible. And here is the example formulation of knapsack problem in our JijModeling, and on the left is the formulation code, and on the right is the mathematical output that is automatically generated from the left. Yeah. So, and JijModeling 2 is can be viewed as a total programming language based on simply typed lambda calculus. And in applications, we do not need full alpha or beta equivalence, although some limited forms of substitutions needed in the second application. And this is because we treat formal transformation and queries on expressions, but not optimizing the variation of the program. Okay, so as promised, the rest of the talk has two main topics. Both topics rely on the formal AST information and on the powerful inference mechanism provided by Egglog. Okay, so let's go on to the first topic, comprehension ensugaring in math output. So as a background, we first discussed the treatment of summation symbols or bound variables in JijModeling 1 and 2. Previously, users had to create an artificial element object, I here, and together with its domain N here, and this kind of artificial syntax is really unpopular, so we introduce higher order functions such as map, filter, or flat map to so that subscripts can now be represented as bound variables. And we also introduced the Python decorators that allow users to write those expressions using comprehension syntax like this. And under the hood, it produces function source code and the symbolic transformation on ASD. So when we process comprehension syntax, we desugare it using flat map, and filter as in the standard transformation. So this gets like this. This is fine as internal representation, but if we translate it literally to mathematical output, the result is not human readable. So the challenge is, how can we convert equations involving higher order functions back into human readable mathematical equations? So we consider resugaring here. So we regard mathematical output as a program transformation and consider resugaring the comprehensions. There are two layers of the rules here. So the first layer transforms expressions into comprehensions, so these rules. And under the hood, it calls the second transformation to resugar membership relations into the right-hand side of comprehension syntax. And throughout the transformation, we bind fresh variables for each for class and to avoid name collisions. This already gives much better result, but still not human readable. So there are so many rebindings like this or like this, and so we want to reduce such rebindings, and to overcome this, we introduced another optimization path to reduce unnecessary rebindings, and of course we used Egglog here. And on the right is the excerpt from the rules, and the equality saturation and extraction feature helped us a lot. And rule set feature also let us flexible control over execution order. As an outline, we assign high cost to let expressions so that expressions avoid unnecessary bindings, and we also assign lower cost to the variables bound later in right-hand side because it is more likely to appear in the left-hand side. And we union both sides of let statements, and when the left-hand side of comprehension is a single variable, we unload its definitions. And with these rules, the mathematical output becomes much more concise and close to what human would like. Okay, so in summary, JijModeling provides powerful mathematical output, but high-order functions made the direct output less readable after comprehension desugaring. The solution is to pass resugar back into the comprehension syntax while rebinding everything to avoid name collisions. Then we apply an optimization path to reduce rebindings. And in most cases, this finishes within 100 milliseconds. So we treated mathematical output as program transformation plus optimization, and as a bonus, even programs originally written directly with filter or map or flat map can also be displayed as clean mathematical notation. And we also register type information of subterms into Egglog database and use them to fine control the rendering. So that database feature really helps us a lot here. Okay, so next we move to the second topic, declarative constraint detection with Egglog. Okay, so this topic is a continuation of last year's talk. In mathematical optimization, some specific kinds of constraints can be exploited to speed up solving. Examples include SOS 1, 2, and 1-hot constraints. And some solvers provide dedicated APIs for such type of constraints. However, users are not necessarily a mathematical optimization expert and may not know that their formulation contains such useful constraints. So it is therefore valuable if the modeler can detect them automatically, and this is what JijModeling is able to do thanks to the model data separation. So as an example, An SOS1 constraint is a constraint over a family of non-negative variables, x, y here, that demands the at most one variable is non-zero. And users write such rules using equations rather than symbolic, this is SOS1. So if all variables are binary, it can be written as just their sums are at most 1. And for general non-negative variables, not necessarily binaries, we can express it as like this, with fresh auxiliary binary variable delta i's, and each upper bound of each xi mi, and we express this as a SOS1 on deltas and this kind of upper bound constraint. Well, so, and if you want to detect general non-negative variable, SOS1 general non-negatives, so this kind of multi-step rules, JijModeling 1 needed to do back and forth between egg and last, and we also didn't make use of extraction features there. In contrast, in JijModeling 2, Egglog's logic programming paradigm allows us to do this completely inside Egglog, and we can also use generalized extraction or querying feature to extract a term representing the domain of detected SOS1 constraint. Okay, so there are two main challenges. The first, we want to detect equivalent patterns all at once. For example, we want to detect both of these. These are algebraically equivalent, of course. So by a single pattern, and of course, equality saturation is a natural tool for this, and JijModeling 1 uses egg, and new version uses Egglog. And the second challenge is more subtle. How do we handle instantiations of bound variables correctly? For example, to detect SOS1 constraint over general non-negatives from conditions like constraints like this, so we must combine information from the constraint on binary variables here on even i's and upper bound constraints, parameterized upper bound constraints. And JijModeling 1 used ad hoc trick. It requires upper bound constraint to have exactly the same subscripts as binary SOS1s with possibly wider domain. But JijModeling 2 now abolishes element object and switch to higher order functions. So the JijModeling 1 trick just works because there are element type and the elements are fixed globally through the, that somehow works. So we have to devise a new trick to overcome this. And this led us to a trick inspired by Henkin constants, which propagates paths without proper built-in support for bound variables and substitutions in the Egglog. Okay, so what is Henkin constant? Henkin constant is used in the proof of the completeness theorem for first-order classical logic. And in short, Henkin constant is a conditional witness for an existential formula. Yeah, it is somewhat looks similar to scoring variables in computer science, but the direction and the logical rule are subtly different. So in the Henkin construction, we repeatedly extend the theory T by adjoining Henkin constant and Henkin axiom for each existential formula. The idea here is not the theorem itself, but introduces a conditional witness for an existentials and use it to propagate facts. Okay, so let's see how our detection algorithm work in Egglog. Suppose we are given with two constraints that jointly constitute an SOS1 constraint on even x's. So JijModeling 1 first encodes each constraint as an Egglog rule, possibly with premises. While doing this, it attaches nonces to each bound variables. And this makes the variable act like Henkin-like constant. Okay, so for upper bound constraint, we declare a rule saying that under the premise that I is less than n, this upper bound constraint falls, and we also register this particular unique constant I98 together with the fact that it fulfills this premise. And for upper bound, for this constraint, as this is not parameterized over any parameters, so it is just assertion that this sum is at most 1, and we also register nonce variable or Henkin constant for this bound variable I that fulfills I42 is less than n, and it is even. So then we register SOS1 detection algorithms rules and run Egglog. The first rule just declares just that for binary variables, the SOS1 and for binary variables, if its summation is at most 1, then it is SOS1. And the second one is just combines binary variable SOS1 and upper bound constraints and lower bounds, and to get general SOS1s. So then, so because the nonce carries the bound variable facts, Egglog can connect the two constraints and derive the SOS1 structure over X. So the first SOS1 is derived just immediately from the first and this, and then it infers that X or xi42 always satisfies this upper bound constraint, and therefore X is also SOS1, satisfies SOS1. Okay, so this worked for simple cases, but we also had to optimize the premises of the generated rules to have practical performance. For one model with the constraints on the right, this Egglog did not terminate even after an hour. At first, we thought that the cause is the explosion in quality saturation, but it was not the case. After inspecting the trace log, it turned out that Egglog did not even reach the equality saturation after an hour. And the issue was that a constraint premises had been encoded a single membership like this. Yeah, it's quite huge, and Egglog got stuck on this. The fix was to apply the comprehension ensugaring from the first part, and it gets like this. Yeah, it's now decomposed into several conditions and now human readable and really debuggable. And now Egglog gets happy with it and terminates in less than 1 second. Okay. In summary, in our previous implementation, we achieved constraint detection modulo equivalence using egg, but detecting multi-step constraints will cumbersome because it requires back and forth between egg and log. But JijModeling 2 solves this more declaratively using Egglog's logic programming paradigm. And although Egglog currently lacks proper handling of bound variables and substitutions, the Henkin constant-like trick lets us propagate information across bound variables. And the practical lesson is that we must simplify Egglog rule premises, otherwise Egglog may get stuck before reaching quality saturation. Okay. Now we move to the conclusion. Okay. JijModeling 2 is a mathematical optimization modeler written as a Python EDSL and implemented in Rust. And we introduced 2 applications of Egglog to mathematical optimization. And the first contribution is readable mathematical output for models using higher order functions. We formulated this as program transformation and optimization with ensugaring into comprehension syntax and equality saturation rebuilding for rebinding optimization. And the second contribution is Egglog-based declarative constraint detection using Henkin-like constants. And one important lesson is that gigantic premise can choke Egglog before equality saturation. Okay, thank you for listening.
Okay, thank you. We have time for a few questions. Hi, thanks for the talk. So you mentioned that things like beta reduction are not considered. So I would suspect it's relevant to hygienic macro, because in resugaring, if you have such binding, then the hygienic things matters. So is it the case? And if it's really about you don't need it, or it's about Egglog cannot support the solution for hygienic macro?
Kind of it sounds useful to me. So currently we are just generating random numbers by hand in our side. So if Egglog provides us the hygienic variable generation, it should be useful to us. Yes.
Okay, let's thank the speaker one more time.
Thank you.